I'm Robin. So this is the question which was asked in the GATE 2023 physics question paper. Now this question is related to the solid state physics, and these are the subtopics. One is the free electron theory and the band theory of the solid. You can watch these lectures if you wanna understand the concepts which are related to this question. So let's read the question and see how we can solve this. So for non-relativistic electrons in a solid, different energy dispersion relation with different effective masses Ma star, Mb star and Mc star are given in these plots. So we have to identify which of the behavior uh, with the different masses is the correct in the four options. So basically we have to find what sort of mass each of the curve can be represented by. Okay, so there are different approaches to solve this question. Now the first is a very simple approach because in solid state physics we know that the energy is given by h bar square k square by 2m for the free particle. But in solids, the dispersion is basically h bar square k square by 2m star, where m star is effective mass. Right. So now the point is we have to observe for the three curves. So the curves given are as such. So there is one curve like this, there is another like this, there is another like this. So you can see the curvature of three curves are very different. And this is represented by Ma star, this is represented by Mb star, and this is represented by Mc star. So now if you see for these three curves A, B and C, if you write the corresponding in the dispersion relation, it would be nothing but EA as h bar k square, that it is E versus K, by 2Ma star, EB as h bar square, now one way to understand what would be the relation between the masses of the three dispersion relation would be, now these are the equation of the parabolas and with the relation as x square 4ay. If the parabola is this is a parabola of such form. If you have this as y, this as x, and this is the distance from the vertex and this is the focus, so this is a. So this is the corresponding equation. So you can simply translate this relation as this equation. So your k star, k square is 2m star by h bar square e. So this is basically your x is k and your e is y. So your a is the which is the distance from the vertex to the focus, which is directly proportional to m star. So now you can see for these, for a, b and c, this distance for a is greater than b greater than c, because for the parabola like this, the vertex is far, the focus is far, and for the parabola like this has to be there, right? So this is a for this parabola. So according to this, the condition for this distance is this. So implies that your MA star has to be greater than MB star greater than MC star. So which is option D. Right. So we have an answer which is this. Now, in exam, people think through different minds. So this is one of the approach. But what is the exact approach? Now here we have approximated the dispersion relation equivalent to free particle. But in general, in solids, the effective mass is described by the h square by second derivative in the energy with k square. So if you look with this argument, now d square E by dk square is large for A it is small. For A it is small and for C it is large. So in this case it's related to the curvature of the dispersion relationship. So now you can see for this case, this is basically equivalent to d square by. Now you can clearly see in this picture for this, for A, d square by de square is less, which implies the MA would be large because MA square is inversely proportional to d square EA by dk square. So now you can clearly see, even with the dispersion relation argument, the curvature of the dispersion relation, and using this formula from the band theory of solid concept, the MA star has to be greater than MB star greater than MC star. So this was the second approach, but the answer with this is also option D. So in this problem, we have seen in the solid state physics, the one way to solve this is using approximation that your dispersion relation can be approximated as a free particle dispersion, but with mass which is not the normal mass, which is the effective mass in the solids. And second is from the band theory, which is which is by this the mass is related to the second derivative of energy with k as this. So this question is related to both the free electron picture and the band theory of the solids. Thank you.